Hi, my name's Harry. Welcome to another episode of Welding Fabrication. Today we're going to be looking at safe setup, shutdown, and some basic little tips for getting yourself started for TIG welding. So setup of the torch itself. So I've got the torch body with a trigger on the back, and what we've got is some of the component parts. We've got a gas lens, which we're going to screw into the front of the torch, like so. This is a 2.4 gas lens, and that corresponds to our tungsten electrode that we're going to be using. So I've got a 2.4 collet as well. And what I'm going to do is there's a slight shoulder on this collet and a split down the other end. What I'm going to do is take that shoulder and I want to push the tungsten, sharp end of the tungsten through there, and then I'm going to feed that into the back of the torch like so. I'm doing all this with the machine off. You can do it with it on, but just to reduce the chance of getting electric shock, turn the machine off. Backing cap, it's quite important that O-ring is intact. So when we slide it over the back of the torch, what effectively happens there, this is just nipped up like so, the gas lens, and as this collet slides in, that slit compresses into a tapered barrel in the back of the gas lens, and then the backing cap pushes onto it. So whereas it's nice and loose at the moment, we can just nip that up just ever so slightly. And there's no real pressure on that. You can see already that's nice and tight. I'm going to just about force it through, little tiny nip, and that's nice and tight. What I'm going to do is I'm going to put the ceramic gas nozzle on the front, and then I'm just going to back this off, and I'm just going to reduce my stick out. And I'm going to have a stick out in this occasion because using the gas lens, we get a deeper flow or further flow of gas in a straighter proportion, which basically means that we'll call it more laminar flow, which in turn means that you can have your stick out slightly longer and potentially your gas flow ever so slightly lower as well. So a gas flow rate, if we set that on our regulator, so let's nip that there. Our gas flow rate on a regulator, I've set that so it's set at it's approximately 7 litres per minute. So anywhere between 5 to 8 is any more than 8 would be a waste. So what we're going to do is I've set the torch up. Our return clamp is on, and we run an electrode negative. So you can see our return clamp goes into the positive port on the machine. And what I'm going to do for you, cut the little safety things as well, filler wire. Depending on what we're doing, we're using 316 stainless, and the filler wire is a 316. And you can tell this by on the tab, there's a flat compressed tab, and you probably won't be able to see it very clearly, but it says 316L. So that's a good indication for your filler wire. And what I will do is just take the end of the filler wire like so and just fold it over. So we've got a little hook on the end. 2 folds. One, when I'm welding, I know which end is hot, so I can identify which end to pick up to make sure I don't burn my fingers. And secondly, that is going to hurt less when you poke it in your eye than that end there as well. Okay, so we've bent our filler wire. There's a slightly shorter backing cap there, which could be an alternative using a smaller tungsten. Could be down to access as well. So if you've got a tighter space to get into, there's slightly different, button backing cap as well, which sits right tight against the back of the torch head. So we turn the machine on. We'll go through a cycle of functions on the machine. I'm just going to go through a couple of the functions very quickly. We'll go through the basic ones for now, and we go through some of the other ones at a later date. So top functions here. We can either select TIG or stick welding to MMA, so we can do MMA with this machine as well. So when the lights come on, that'll show it being lit as, there we go, so lit as TIG. We're on DC electrode negative, you can see in the brackets there, rather than AC. AC, so if we were welding TIG aluminium, something like that, we would use AC, and we'll go through that on a different session another day. We're using high frequency opposed to lift starts. You can actually set your function so that you arc up by touching down the material, short circuit, and then as you draw away, causes a massive resistance, and then your current builds up. We're going to use high frequency, so we're going to set our gap first, press the trigger, and then it's going to bridge the gap and then create the arc itself. Next one along, we've got what we call 2-touch or 4-touch, sometimes known as 4T or 2T, sometimes people know it as latch. And basically it's a function where you have your finger on the trigger, take your finger off, and then so it arcs on and then arcs off, or you can see the arrows in both directions. On this function here, you put your finger on the trigger, take your finger off, it arcs up. Finger on the trigger, finger off the trigger, stops. Other function here, we've got pre-programmable settings we're going to look at today really. And on the bottom setting here, we've got our what we call slope in. So we're going to set a little bit of slope in actually. We'll set it at 1 second. And what that basically means is it's going to go over a period of 1 second. When we put a finger on the trigger, it's going to take a second to go from 0 up to our running current, and I've got it currently set on 90 amps. This helps adjust our current we're going to be welding at. Next function along is our slope out or slope down, and we're going to set that again. We'll set it on 1.5 seconds, and the next function across from that is our post gas. So our post gas is effectively when we stop welding, it's the number of seconds the gas continues to flow afterwards while the molten pool is still solidifying. So what we're going to do on this particular function, rule of thumb, I've got it set on 5 seconds. I normally go between 1 second for every 10 to 15 amps approximately I'm welding at. So I'm going to set it at 6 seconds. That's more than enough, more than ample in terms of what you're going to be doing. Okay, so what we're going to do is, now we've set the machine up, it's all on and running. I've already tacked a piece of material up, and the tacks you can see are nice and shiny and silver, so I've held for the post gas on the tacks, and I've tacked this what we call autogenously, so which means without filler, and we're going to weld with filler, which is homogeneously, so that is with filler. So it's a homogeneous solution of the parent material and the filler wire combined. So angles of slope and tilt are very important. I will put my gloves on in a minute. Angles of slope and tilt are very important, and it's positioning again of the torch, how you want to hold it. So some people prefer to hold it with their index finger on the top, and they hold it with the body of the torch like so. Some preferably, depending on what position you're welding as well, some people hold it in the palm of their hand with the thumb on top. In this instance, I'm going to hold it with create like a V shape, drop the torch in to that V, and then my index finger I'm going to bring over onto the trigger. I'm just going to grip the side of the torch with my thumb, and I'm just going to rest my fingers around the side, tuck them back out of the way so they're nowhere near the heat. And basically that's my position. So nice and comfortable. Torch is nice and slimline anyway. So, and angles of slope. So if that was 90 degrees, so we've got 90 degrees. So I'm left-handed, so I'm going to go direction of travel. Always going to push, not drag. So I'm going to go left to right, being a left-handed person. And my angle of slope is going to be dropped back to a 75 to 80 degrees. And my angle of tilt, as it's a 90-degree angle, we're going to go in at 45 degrees, so upright. So we're going to drop back to 75 to 80. Filler wire, I'm going to have the same principle. So my filler wire is going to come in, and it's going to come in at 10 to 15 degrees, and in terms of slope, and angle of tilt, again, it'll be 45, so in the middle. Basically, what it means is that the angle of slope between your filler wire and your tungsten should always make 90 degrees, whether at 10 or 15 degrees on the filler, or 75 to 80 on the torch. Okay. My arc length itself, so between the tungsten and the parent material, I'm going to have a set an arc length for approximately 2 millimeters. And once I've created that molten pool, just like when I've done the tack, I'm just going to dab the filler wire in and move along. Dab, move, dab, move. I'm only moving about 0.5 millimeter each time, little and often. Little dab, little movement, and then a little dab again. So a little movement on the torch, little dab of the filler wire. Okay. Right. So, we've set it at 90 amps. So we're going to have a slope in of about 1 second. So you're going to see a slight build of the current over 1 second, and then once we've built that current up, it's going to be running for 90 amps until we stop, and when we stop, that's going to drop down from 90 back to 0 over 1.5 seconds. Okay, right. Mind your eyes. So I'm going to create that molten pool, little dab of filler wire, little dab, little movement. And each time I'm just moving forward, then I'm dabbing, move forward, then dab. I'm not doing them both at the same time. It's quite important to make sure that you move and then dab. By not putting filler wire in the tacks as well, means they're not lumpy, so we can fuse them in and melt straight over the top of them. Little movement, little dab, little movement, little dab, like so. Right, I'm going to hold for my post gas. Hold for the post gas like so. So just allow it while it's solidifying. And you can see there, there's nice consistency of these ripples going through the parent material. Nice consistent ripples, so every movement, little dab of filler wire, little movement, little dab, little movement. It's really important to keep a steady hand, so when your torch is in play, so when you've got your torch in play like so, it's really important to keep a nice steady arc, so basically nice and steady. So if you sort of try and balance your hand or rest on something to keep yourself nice and steady, stop you shaking. It's important not to rest your ceramic gas nozzle on the material all the time, because what tends to happen is it tends to snag, and then it's very difficult to move it along, so you tend to be more jerky. So it's important to be nice and free flowing when you're actually welding with TIG. Okay, thank you very much.